So we're taking a look at fighting the flu. So we're looking at the influenza vaccine specifically. So the presentation outline is we're getting to know the virus, seeing how the vaccine is made, why is the vaccine different every year, and can the flu be stopped? The influenza virus. This is a look at some information from the CDC. The flu virus is a virus that targets the respiratory system. So we're looking at your lungs, your nasal passage, and just breathing in general. The flu can be very dangerous. Most healthy adults with a good immunity are going to recover in a few days. But children who haven't really developed a good immunity yet, or senior citizens who have diminishing immunity, are going to face more serious complications, and it could even lead to death. Also, people who have more chronic illnesses are going to be more susceptible as well. The flu is spread through droplets, which droplets are things is when the virus is spread through, say it could be your saliva. So if you're talking to someone who's infected and the virus floats in their saliva and through the air, you could be infected that way. We also look at the period of contagiousness, and the period of contagiousness can be before any signs or symptoms ever arise, and even after your symptoms have subsided. So I could be infected with the flu and not even know it, not feel it, don't have any signs or symptoms, and go to Walmart and have a conversation with the cashier and spread the influenza virus to them. So once you are infected, and if the scientists guessed the wrong virus or vaccine and I still got infected, another way to treat the virus would be to get antiviral drugs. So now we're going to look at how the flu vaccine is made. 142 national centers monitor the strains that are causing the disease throughout the year. And so all the doctors and whatever are recording incidents of the flu, and all this information is being reported to these 142 national centers. And then these 142 national centers are then going to send this information out to 5 World Health Organization collaboration centers. So these are 5 centers that are around the world where scientists are going to come together and use all this information that they've been given to come up with the best idea for a flu vaccine. So they determine the strand, these 5 centers, they determine the strand that is most likely the cause of the virus each coming year. And they're looking at factors of the virus. So they're looking at what population is being infected, what age range, what type of people are being affected, and where in the world are people being affected. Once they determine the strand that is likely the cause of the virus, they start making the vaccine. So how is a flu vaccine made? They need to reproduce the virus. So to reproduce a virus, it has to have a host. So most of the time the vaccines are made in chicken eggs. They inject the host, or they inject the virus into these chicken eggs, and the virus replicates inside the chicken eggs. Then they take it and they kill the virus. And so these dead virus are going to contain foreign proteins to people. So when you're injected with these foreign proteins, your body responds to that and say, these are not mine. And in its response to that these proteins are not mine, it makes antibodies against it. So these foreign proteins are also known as antigens, and they create the antibodies. So if we're looking at this, this is the antigen or antibody antigen complex. So we have the antibody here. It is made from this year's strand of the virus. So if the scientists got it right, this is going to be a perfect lock and key match. And the antibody is going to be able to attach to those proteins on the surface of the virus, and the virus is not going to be able to penetrate into the host and replicate because it's too big. It makes a structure that's too big, and the virus has to get into the host to replicate. The host has the DNA and the ribosomes for reproduction, and the virus isn't able to replicate outside of a host. It needs a host for replication. So if we're able to trap the virus in this antibody antigen complex, then it can't replicate and can't get infected by the virus. So why do we need a new vaccine every year? Well, if you look at most of the time, you get a vaccine and the virus is gone. You're never going to get that disease. But with the influenza virus, it mutates every year. So one vaccine for this year may not work for next year's mutation of the disease because it has to be that lock and key mechanism. If the lock doesn't fit the key, so if the antibody does not have the key harness for the antigen to attach to, then it's not going to be able to trap that virus outside of the host, and the virus is going to be able to go in and replicate. So we have to have a vaccine every year that matches that specific strain that's infecting people in the given year to prevent it from being able to replicate in the host and infect people. That's essentially why. And the influenza A virus is the one that seems to be able to have continuing surface proteins that mutate. So, can it be stopped is the question. So, scientists want to come up with a universal vaccine. They want to eradicate the virus. But is it possible? So one look is they're looking at these surface proteins called M2 proteins. They're an ion channel protein that transmits the virus. So if say it's a straw essentially sticking out the side of the virus, this little straw, and the straw is going to stick into the host and it's going to send that virus into the host cell to replicate. And the thing with the M2 cells is the M2 proteins, they barely mutate. So you could come up with a vaccine that contains all mutations of the M2 protein and make an antibody that way. But what they've seen when they've tried this on mice is that the mice still were getting infected, but what they also saw was that the mice were not dying. So their thought was like that you're still going to get infected. You're still going to get the signs and symptoms if you've got just the M2 vaccine, but it may make it where the virus is less deadly. So people who are more susceptible to death, so it could be like children or senior citizens, would get the M2 vaccine in addition to the regular vaccine. So if they actually do get the virus, the virus may not be deadly. They also are looking at the NP protein, which is an interior protein in the virus, and they would take that protein out of the virus and put that into the DNA of the host, and they saw that the host may elicit a larger immune response, so be able to get the virus out quicker. But from that, you're going to be infected. It's still going to infect you, but maybe you can beat the virus faster. So what they saw with this was that mice survived, but when they tried this on other animals, the other animals died. So from that, as of now, the M2 and the MP are really not the answer, and neither will eradicate the virus. From their test on these two different proteins was that you're still going to get infected, you're still going to show signs and symptoms, but there was hope in that, especially with the M2 proteins, is that, maybe with this, you won't be killed by the virus. You have less chance of death. But as of right now, there is nothing that suggests we're anywhere close to finding a vaccine that will get rid of the virus. But they're still questioning, is it possible? And scientists are still studying to try to see if they can get rid of the virus completely. So this is a look into influenza vaccine. I hope this was helpful.